Welcome to Chips of Math Physics. Today we continue our questions on the ordinary differential equation. We want to use this medium to thank all our supporters, sponsors across the world. When you touch a life, you change the world. And this is what humanity is all about. ODEis, let me take you through ordinary differential equations. Assuming we are given an equation, and the equation is x squared plus 1 dy over dx is equals to x y. The idea is to isolate x on one side and y on one side. So let us see what we are supposed to do. The equation is x squared plus 1 dy over dx is equals to xy. So we need to rewrite this so that we will have x squared plus 1 dy, and this will be equals to x y dx. Now this differential equation, we might need to divide both sides by x squared plus 1 and also divide both sides by y, in order to get x and y separately. So let us go ahead and do that. So we simply have x squared plus 1 dy. Divide this by x squared plus 1. Then also divide this by y. And this is equals to x y dy dx. Divide this also by x plus 1 and divide this side by y. If you notice what happened, here we will have x squared cancelling with this, and here we will have so here we will have y going with y, so that our question now will become, if you notice, x squared plus 1 is cancelled with x squared plus 1. So we are left with 1 all over y dy, and this is equals to, here we are left with x, so it is x divided by x squared plus 1 dx. Now let us take the integral of both sides. So we are going to integrate 1 all over y and integrate this side. Notice what happened. If you integrate 1 all over y, you will simply get ln of y. So this will become ln of y. ln of y. You can add some arbitrary constant, call it c1, but it doesn't really make sense because we still have c2. So let me take both c1 and c2 to the other side, or if you wish, you can still add, so that we have this becomes some constant c1. Let's take it to be that, so that we have the integral of x divided by x squared plus 1. We need to use U substitution. In case if you are new to this channel, you can visit my previous video so that you know how to use U substitution to do that. Quickly, let me show you what you're supposed to do. If it is U substitution, we can let U to be x squared plus 1, so that we differentiate this, so du will simply be equals to 2x dx, so that if we evaluate that, we have a half du is equals to x dx. For more on how to use U substitution, you can watch my previous video. So that what we are having here now for the integral of x divided by x squared plus 1 will simply be a half ln ln of what we have, which is our u, which is x squared plus 1, and this plus some constant c, plus some constant c. Remember, we have some constant c1 somewhere, and now we have this supposed to be c2, but then we can rewrite this so that our final solution becomes ln of y. Ln of y is equals to a half ln of this u, which is x squared plus 1 plus some constant c, and this is our implicit answer. If you want to solve for the explicit answer for this, to make it explicit simply means you simply need to separate x and y to be different, independent on their own. If you need to do that, what you simply need to do is to raise both ln of y and half ln of x squared plus 1 plus c to exponent. So we can actually raise all this. We can raise them by some e. You raise this by e. So if you raise that by e, you will now try to solve using the exponential function. But this implicit answer is acceptable. So you can have your answer like this, or you can as well try to solve it explicitly by saying exponential ln of y, exponential ln of y will be equal to exponential a half ln of x squared plus 2 plus some constant c, what this will give us will simply be y to be the ln of root sign of x squared plus 1 and some constant c, or we can say exponential c. It doesn't really matter. You can, as some textbook we have it, they use a and b. So if I use b, for instance, our final answer here will become y is equals to some constant b or a of ln of what we have in the bracket, root sign of x squared plus 1, close the bracket, multiply by exponential c, and this will become your implicit solution, the explicit solution. But when you reach here, this is the solution implicitly, but this is the explicit solution. I hope you found this video helpful. Otherwise, see you in my next video. Galagash.